Here we have honors algebra 2 math problem. Here we have an infinite series. So we have to evaluate this infinite series. So for that, we have to plug in I is equal to 1, 2, 3 into the general term. So when I plug in I is equal to 1, I'll be getting the first term. When I plug in I is equal to 2, I'll be getting the second term. In this way, I'll be getting the terms of the given series, and we have to add them all because we have summation. Summation means we have to add all the terms we are getting when we plug in I is equal to 1, 2, 3. Okay, when I plug in I is equal to 1 into the general term, so here I have 1 over 3 to the power 1. That's nothing but 1 over 3. Positive. When I plug in I is equal to 2, I'll be getting 1 over 3, the whole square. Then when I plug in I is equal to 3, I'll be getting 1 over 3 to the third power. When I plug in I is equal to 4, I'll be getting 1 over 3 to the fourth power. And it keeps going infinitely. Okay, so here I've added all the terms because we have summation. Now we have to evaluate this series, infinite series. So for that, I have to identify the type of the series we have over here. So it's very simple to identify this series because each term is multiplied by 1/3 to generate the next term. Look at the first term, 1/3. So when I multiply this one by 1/3, so I'll be getting 1/3 to the second part, that's the second term. If I multiply the second term 1/3 by 1/3 whole square by 1/3, I'll be getting 1/3 to the third part. If I multiply the third term 1/3 to the third part by 1/3, I'm getting 1/3 to the fourth part. So clearly it's a geometric series with the common ratio 1/3. So because we multiply each term by 1/3 to generate the next term, so the common ratio is 1/3. Since the series is infinite, so this given series is infinite geometric series. Whenever I want to evaluate infinite geometric series, the value of the common ratio R must be in the interval -1, -1 less than or less than 1. So the value of the common ratio in the given geometric series must be between -1 and +1. Then only we'll be able to evaluate the given infinite geometric series. What if the value of R is out of this interval? That is, the value of R is maybe greater than 1 or maybe less than -1. Then the given infinite geometric series is divergent. We will not be able to find the value of it. So if the value of the common ratio R is between -1 and +1, then the given infinite geometric series is convergent and we'll be able to evaluate the value of the given infinite geometric series. In our problem, the value of the common ratio R is 1/3. Which is in this interval. That is, the value 1/3 is between -1 and +1. Because if you try to find the exact value of this one, it will be 0.3333. It keeps going. So clearly, this value lies between -1 and +1. So the value 1/3, the value of the common ratio 1/3 in our geometric series is between -1 and +1. So we will be evaluate this infinite geometric series because it's convergent. Okay, so whenever we have infinite geometric series and I want to evaluate, infinite geometric series and also it is convergent. So the formula to find the sum of the terms in the series is going to be A1 divided by 1 - R. So here A1 is nothing but the first term of the series. In this case, it's 1/3. And 1 - the value for the common ratio is 1/3 again. Okay, here we have to simplify this. Let's write this fraction in numerator as it is. Now I have to simplify this 1 - 1/3. So here I subtract a fraction from an integer 1. Whenever I subtract or add a fraction and an integer, I have to multiply the integer by the denominator of the fraction. So once I'm done with this multiplication, I can take this denominator as a common denominator. So 1 times 3 is 3, -1. I'm taking this 3 as a common denominator. So 1/3 over, so the simplification of this one is 2. So we get 2/3, the fraction 2/3 in denominator. Okay, so here I'm writing this fraction 1/3 as it is. And I am writing this division as multiplication. And I take reciprocal for this one, it will be 3/2. So this 3 will cancel out. I get 1/2. I have evaluated the given infinite geometric series. So its evaluation is 1/2.